about different statistical packages and kind of like the pros and benefit and cons of each statistical package, or some of the ones that are very commonly used. At least I've come across in my time as a statistical consultant, and I am a statistical consultant from UoW. And so this was actually based on a talk myself and Marika and Alberto gave for the Data and Decision Science Initiative. So I want to give credit to them, as this work, of course, was done in collaboration with them. Yeah. So when it comes to deciding on a statistical package, I think when my clients ask me which stats package should I use, the first response, as in many ways is always our response when it comes to questions from clients, is, well, it depends. And it depends on a couple of different things, what is it that this client wants to do? What is it that you want to do? Do you want to do data manipulation? Do you want to get some descriptive statistics out? Is data visualization a big component of what you're interested in? Will you be doing some complex models? Is your data kind of complex? Is it non-linear? All of these kind of questions are going to weigh into that decision making, as well as kind of what's your research question look like, right? Are you dealing with statistical inference, or are you just trying to describe and display patterns? Those kinds of things all weigh into the choice. And finally, we also have to consider, what does the actual data look like, right? Whenever we're doing statistical analysis, we're doing it on something. And depending on what your data looks like, it might lend itself more to something a bit simpler if it's a small data set with not a lot of, things going wrong with it, all the way to if it's a very complex data set with, different linking to multiple different sources, or if it's a big administration data set, or it could be time dependent and there's multiple time snippets, and all those kind of things are going to weigh into your decision making around which statistical software is going to be the best to pick. So what I'm going to do in this talk is I'm going to kind of run through kind of the key candidates, at least we see at UoW. And I'm assuming it's going to be something similar at UNSW. And then I'm also going to show you one of the newish softwares. It's been around for a few years now, that we have integrated into our courses at Wollongong, specifically because of its simplicity, ease of use, and because it's really useful for teaching. And teaching, whether you're going to use this software to teach, might have different you might have different requirements than something you might want to use on your day-to-day basis. So, how many packages are there? Well, there's quite a lot. Just on open source packages alone, we've got a huge list. Now, some of these are packages and work with in conjunction with other softwares. But just looking at it from a very kind of broad picture, it can be quite overwhelming as to what specific software you would use, particularly if you just did a random Google search and said, I want to analyze this type of data, what should I use? When we add in the proprietary softwares, that list grows even longer. But you do see kind of your standard or your kind of core most common proprietary softwares listed there. Things like STATA and SPSS and MATLAB and all that kind of thing. So, choosing between them can be tricky. It can be difficult. So it's good to have a kind of rough idea about each of them. What are their kind of the key benefits, and what are the key cons? So the softwares we're going to be looking at today are SPSS, which is probably the most common software I tend to see amongst my non-statistician clients. But we also, I get a handful of people who are using STATA, some people who are also using SAS, particularly those who are working in the government sector. Also, you've got your programming languages there. You've got Python, R and RStudio, and I have to admit I'm a bit biased. I'm an R and RStudio user, so I'm a big fan of of that one. And then down the bottom I put Jamovi, and this is the software, the graphical user interface to R, that we've started to integrate throughout teaching. And so we're going to have a quick look at each of them. And then what I'm going to do is I'm actually going to run through a quick t-test just so you can get a sense of what that looks like in each of these softwares and really get an idea of, whether or not that's one you might want to use in your own research. So, starting off with, like I said, the most common one I tend to see amongst my clients, IBM SPSS Statistics. This is a commercial product, so you have to pay a licensing fee in order to use it. It was first released back in 1968. I think it was taken on by IBM in the early 2000s, late 90s, around that time. And it's a spreadsheet-based graphical user interface with point and click menus for analysis. So if you're someone who might have only, used Excel, this might be a good transition statistical software for you. It allows you to really see your data so you can get a sense of what's going on. And then in order to perform the statistical analysis, you don't have to write any long code. You can select from a menu of options. So what's the key pros of SPSS? Well, it's widely used in teaching, particularly in undergraduate subjects. So a lot of people um, have had some experience with it at some point in their lives. There's many online resources for SPSS. You can, use it. You can kind of do a quick Google, and there'll be pages and pages of reference material for you to access. As I said before, it's menu driven, so you don't need to learn how to code in order to use it. And it's got most of your standard and most common advanced analysis methods within it. So you can kind of, do most of the things, the vast majority of things you're after for a standard statistical analysis. The data visualization component is quite good. It allows you to customize your graphs fairly easily just by double clicking and editing it kind of manually. It's got good missing data. It can handle missing data. There are multiple imputation options. You can even do Bayesian analysis. And for version 28, they've introduced meta-analysis. And they've also introduced a workbook facility, which is kind of similar to your R Markdowns or your Jupyter notebooks, where you can actually embed text with your analysis and your syntax in order to kind of make your analysis more reproducible. So that's also kind of a new feature part, well, newish again. That was version 28, which is a couple of years ago now. But that's a feature that might make it more appealing to those who want something a bit more reproducible. What are the key cons? For me, one of the key cons is that it is quite repetitive to use when you're using the menus. You have to kind of click multiple things multiple times in order to load up screens and in order to perform your analysis. There's nothing worse than going through all this process of clicking, 100 different buttons and then realizing you failed to click one thing and have to go back and do it again. And so, like that is consuming. There is a syntax option, so you can use kind of more like a coding language in order to do it. Yeah, Simon, you got a question? No? Yep. Okay. Uh, um, so you can use kind of a code to speed up things if you're using it over again. But that syntax can be quite confusing. And one of the key draws, of course, of syntax is this is meant for someone who maybe not be too familiar with coding. Another key con, something that you find a lot, is that it tends to output a lot. It tends to output a lot of output, which with statistics that you didn't even ask for. And so that can be quite confusing, particularly for someone who's new to statistical analysis or is just kind of getting their feet wet with it. And so people can also miss the key features that they need to extract from that. Now, graphing capacity, I said it's quite good, but it is still limited. You can only really do your standard graphs, your bar charts, your plots, there is a chart builder option within there that does have some more advanced plots, but even that, the options within it are pretty limited. It's not as kind of universal as you might see in some of your other packages. Um, Data manipulation is quite tedious and time consuming. There are features within SPSS to say restructure, what we call a wide data set to a long data set and to split it into multiple files. But it is quite cumbersome to do that, and you end up with, big, large files all everywhere. It's not as easy to kind of manipulate data sets as we might want. And another key problem with it is that it can struggle with large data sets. So if you've got, lots and lots of rows, things tend to get very, very slow when you're using SPSS, partly because you're visualizing the data set, so it actually has to load all those rows. But also just the running of the routines can get quite long. And finally, of course, it is a proprietary software. And so anytime you put a cost on that, that's going to be prohibitive, especially for students, if we don't have, a site license at your various institution or company. So that's another consideration we have to factor in as well. All right, STATA. STATA, I've always thought of STATA as something that my professor uses, kind of thing, back in the day. It tends to be, there's a few people who use it who very religiously use it, but I think it's getting less commonly used, at least amongst my kind of friends and for what I see from clients and students. I think STATA is a good mid ground between a point and click menu-driven thing and some command-based code for statistical analysis. And it does mean that you can do things a little bit more, quickly. It's less forced to use the menus. So what are the key pros? Well, it's reasonably priced for academics and students, so that's good. And it's good for your standard and many advanced methods, just like SPSS. It also includes robust analysis, which is quite nice. I think Stata's real strengths is when you start to do, your survey analysis in Stata. It's really good at handling when dealing with data that comes with weights. And still a lot of big Australian surveys that export their data in Stata files for that reason. You can also get custom do files. Do files are kind of like the script files of Stata. And that can allow you to do some more complex analysis, for example, dealing with stepped wedge designs and things like that. It's used quite extensively in epidemiology, public health, social science, economics. But with any of these types of things, we are restricted by what analyses have been added to those menus. That you can download custom packages, but they can be real hit and miss in usage as well. Um, but the key advantage is with Stata is that it kind of balances that need for some scripting, but while keeping the syntax very simple and still providing you those menu options in order to make it a little bit more accessible for those of us who aren't coders. Cons, well, learning the code is always going to be a bit difficult for everyone, and it is very Stata specific. They are kind of key term code-based commands, which isn't going to really help you learn things like R and Python down the track. The menu-driven options not as user-friendly as other options, and I'll show you an example of this. But the language is quite complex. It tends to have long written statements around what analyses you want to produce. And it is limited compared to some of the open source alternatives. And of course, it is still a paid for software. So those costs and licensing issues are going to apply. And finally, the data visualization in it is pretty rudimentary. It does all the basic things you need, but it's not going to allow you to produce those kind of complex graphs or data visualizations that you might want to be able to do down the track. Alrighty, SAS. So SAS is a statistical software often used in government or pharma, commercial product, so you do have to pay for it. Although SAS does have an online version called RStudio, and academics and students can get that for free. So it's very easy to get access to it. You just submit a little application, and I think they process it in a couple of minutes most of the time. And they will give you access to SAS for free online in order to do your analysis, which is quite cool. So key pros for SAS, it's the gold standard for pharmaceutical trials and governments, although R is kind of increasingly being used. It's really great at dealing with really large data sets. So because the way it kind of works is it's procedural based, it only uses the data when it kind of needs it when you're running a procedure. So that makes it kind of a lot quicker to use than something like SPSS. It's built with data privacy and security in mind, and you can, put passwords on things and stuff. And that's part of the reason why, particularly for, clinical trials and for governments and dealing with administrative data, SAS can be one of those still that go-to choice. The way it works is it runs on code using kind of data and proc statements or procedure-based statements. So you have to kind of lay out all the parameters of a procedure you want to run, and then after you've finished writing that, you click run, and it goes off and does the analysis for you. Key cons, well, menu-driven SAS Studio is not as intuitive as other packages. It's quite difficult to kind of work out how to get your data into SAS and set up in order to then run your procedures. So, particularly for someone again who's not as familiar with this kind of statistical software, it's going to be a little bit difficult for them to access. Again, learning the code, if you want to use the code, it's unique to SAS, just like STATA. So it's going to be quite difficult, not as kind of translatable. Although all software is going to have unique code, it is very much particular to how SAS lays it out. It's mostly dependent on inbuilt procedures. So, if you don't have those options available to you, you can't really run the analysis. And if you're talking about businesses, that cost can be quite prohibitive as well. And like the final point there is I do feel like there's less and less people coming through now who are trained in using SAS. We're going through a bit of generational change as people are using more and more open source software. And that's going to affect its usage, of course, down the track as well. All right. Python. Now, I hope there's no Python people who will be offended here because, like I said, I am an R user, so and people love Python, and there's good reason to it. It's an open source general purpose programming language. Works cross-platform. You can integrate it into pipelines really easily. It was released back in 1989 and has since then really kind of taken over as this number one universal language that people tend to use when it comes to programming. Key pros, free and open source. You can have it on your computer in a second. It's got a nice interface with low-level languages and GPU acceleration. So if you're dealing with large-scale computations, that's going to be really, really useful. It's used extensively in web development, so you can integrate your analysis really nicely with web platforms. It's used in scalable production environments. There are many libraries available to it, so you can get analysis packages that will do kind of anything you want it to do. It can be used with an integrated development environment and also things like Jupyter notebooks and that kind of notebook computing environment. It can be run locally or on a server via Google Colab, which is, very useful, particularly when you're sharing your code with other people. There's no braces or semicolons that you might see in standard programming languages like C++, but using indentation to structure the code. And it's not as steep a learning curve as something like, C++ or C or, those base programming language. It's the go-to for machine learning and data science, and it's got great data manipulation capability from like pandas, the package pandas, and of course the visualization is also really great. It's a widely valued skill, so it's got a lot of pros for it. Cons, number one, steep learning curve. So if you're someone who's just wanting to do a little bit of statistical analysis, run a t-test, for instance, it's going to be quite a steep learning curve for you to just pick up and off you go with it. Its inbuilt capacity, so the inbuilt packages is fairly limited, so you will be using packages. And there's not as many statistics specific packages. as in R. So, Python, very, very universal for all your programming needs. But when it comes to specifically statistics, a lot of that tends to be done in R. Um, the code syntax can be a bit cumbersome for standard analyses, because it is in that kind of more universal structure. So you end up with kind of a lot of nesting in your statements. Um, and I think for me, the biggest drawback here is to do with the fact that in order to find packages, it can be quite difficult because there is just so many. To find, what's a good package in order to analyze your software. PyPI is a repository which you can go to, but there's all sorts of things on there. I had one person describe it to me actually last week as the Wild West of statistical softwares, right? Like there's no real oversight in the same way as what you have with CRAN in R. And so because of that, it can be a bit difficult to find a good software. And also because of that, you get compatibility issues with, sometimes this code was uploaded 10 years ago or, something like that. It's also got high memory usage, although you'll find that for most of your programming based languages when doing statistical analysis. Alrighty, R and RStudio. Well, R is an open source statistical programming language. It was released in 1995. So it's had quite a while to develop an active user base. It's ubiquitously used through an IDE called RStudio. So everyone who uses R tends to use RStudio as well, because it does just make that whole programming process a little bit easier. Key pros, R is specifically designed for statistical analysis. So, it's not just a general purpose programming language, although you can use it in that way. It is specifically designed for statistical analysis. So it has all the benefits of the coding language. It's customizable, it's reproducible, but with that kind of key purpose in mind. It has a comprehensive range of statistical analysis methods in R, and it's kind of common practice now for statistical researchers when they're, writing new analysis methods to also upload or make available an R package to go with their work. I think the Journal of Statistical Software was one of the most cited journals in statistics research because it is just so universally used when we're talking about R software. So it's more intuitive syntax for statistical analysis than Python, and that's my opinion there. But RStudio it's fairly user friendly for beginners, although of course it's still coding, so you're still going to have that steep learning curve. Um, Package developers must make sure that their software has proper documentation and maintained regularly and performs effectively. So part of the requirements to upload to CRAN is that you have to go through this kind of checking process. You need to have all your help files available. You need to give examples. You need to have, you know, you need to do error testings, and you need to maintain that and make sure that it works with dependencies. And every time R updates, you need to kind of validate that, yes, my package still works. So it's got that kind of additional oversight that makes it, you can kind of trust it a bit more, and you're using a quality program, provided it's on CRAN. You don't need it to be on CRAN, but provided it is on CRAN. Tidyverse is amazing for your data manipulation and data visualization and using piped code. You can also use interactive tools like Shiny to make web development and dashboards more accessible to statisticians who might be less comfortable with building a graphical user interface themselves. So you can use a tool like Shiny, so you can share and visualize your analysis and make it accessible to the broader public. And RStudio also has a commercial arm which supports businesses and funds free development. So it's called Posit now, the company, but that also is, you can, if you need to upscale and things, there's a specific company that kind of really looks after you there. Cons, steep learning curve, as would be the case for all kind of coding languages. Dependencies can drop off more easily, and packages do drop off because they do have kind of strict guidelines to be on CRAN. if the package maintainer isn't meeting those guidelines, they do tend to drop off. And so sometimes you might be using a particular package and then it says it's not available for this version of R or something like that. So that can make it a bit tricky, particularly if you're working on a long-term project or you might want to touch base with something down the track. R is very RAM heavy, and it favors matrix multiplications over loops. So if you need to write a lot of loops, maybe Python might be better. But if you're dealing with, large scale linear algebra problems, R is a great tool for that. The R help, because it is written by mostly, statisticians and things, it can be quite difficult for newbies or new programmers to kind of read and interpret. It tends to be quite jargon filled, which can be quite tricky. In saying that, of course, there are online resources that you can Google. There's a big open source culture around R. And so, you can usually find more accessible explanations with a bit of Googling. Um, Sometimes there is a bit of trade-off between the base R and the tidyverse, and some people might be more familiar with the base R, some people might be more familiar with tidyverse, and that means there's kind of two strands of coding that you might want to learn, and that can be confusing. And also, there's less time spent viewing the data than say something like SPSS, where you've got that spreadsheet right in front of you, and so in order to view it, you have to specifically ask to view data, which can be a little bit tedious at times. Um, so that's kind of like, R, where it's positioned. Now, there are graphical user interface that are available that make R more accessible to those new users. And so some of the key ones that are available are Jamovi, which is the one that we tend to use at UoW. But JASP is also really big. I think there are universities who are big on JASP. There's also Blue Sky. And R Commander is another one, or that tends to be more like a code generator, more similar to say something you would see in STATA. So, there are user interfaces that can be really useful at making R-based methods more accessible for the general public. Um, and so the one I'm going to talk about today is called Jamovi, right? And this is what Jamovi looks like. You've got essentially a spreadsheet view, and then this section over here is where all your output will get presented. There's only limited analyses options, although you can add in more modules and do more analysis, and I'll talk about that a little bit later on. Key pros of Jamovi. It looks like SPSS. It kind of feels like SPSS. And that's going to make it a little bit more accessible for people who are coming from SPSS who want to, start to develop some R skills. It has good support and longevity. There's nice modules for analyses and commonly performed procedures. The output is immediately visible. So unlike with SPSS, we have to select all the options and then click OK or click Run. As you click the options, the analysis pops up. And that's really, really useful, particularly when you're teaching. All the assumption checks and non-parametric versions are paired with their analyses. And again, that makes things a lot easier. You don't have to remember 10 different pathways in order to get to your analysis. If you want to compare, the difference in mean between two groups, it's one window you go to. Output is editable. So you can like add comments in and make it, useful, kind of work at it like a workbook kind of style. There's a free online textbook and many online resources. And of course, that's why we're kind of using it in teaching at UoW. Cons, there's very limited, well, not very limited, but there's limited analyses that can be performed here. If you're doing anything that's kind of cutting edge resource, there's not going to be a module written for that. It can't customize data visualizations. And I think that's probably the biggest drawback that we've kind of found is being in the data visualization aspect. Now you can write R code in Jamovi and produce your graphs using, say, ggplot or base R. But that's, again, that's requiring some coding knowledge. It's difficult to output your entire results window to PDF or HTML. You can't just, export it. the dynamic nature of the way Jamovi works can be a bit frustrating, particularly when you're doing transformations of data values. Um, and currently, there's no machine learning modules, no AI modules. Like I said, very, very kind of standard statistical analysis available in it. I just wanted to include this slide, not to offend anyone, but just to say that, Excel is meant for viewing data, entering data, getting some simple, quick calculations. If you want to do statistical inference and, run statistical analyses, don't use Excel. It won't be useful. There are options to be able to, run a regression in Excel and stuff, but it's very, very easy to make mistakes. It's not reproducible. There is Visual Basic Code, but it's pretty awful to use. It's very easy to not kind of fill all your formulas down all the cells. The graphics encourage chart junk. It's just not something we want to be using when there are some kind of good options out there. But like I said, if you're using it to view data or enter data in, or for some simple calculations, you know, it's great for that. And there's a good article called "Friends Don't Let Friends Use Excel for Statistics," which kind of covers all this as well. All right. So how to run a t-test. I'm going to just quickly work through a very quick demo and all these different statistical packages, just to see what they kind of look like. So starting with well, first off, what data are we dealing with? We're dealing with a sample data set, which compares the body mass index between two groups of, and this is from a very famous data set, the Pima Indian data set, of pregnant women, and it's looking at the difference in PMI between those with diabetes and those without. So is there a significant difference in mean BMI between those with and those without diabetes? Okay, so what we're going to do, this is the procedure we're going to follow. We're going to plot our data first with side-by-side box plots, where they're going to check our assumptions. So we're going to check for equality of variance. We're going to perform a Shapiro-Wilk test to try and check for normality. And then we're going to perform a t-test as well. And ultimately, what we're wanting to end up with is some kind of, version of this output. Right? We want to create um, a, a report that kind of has these sections to it, and we're going to use the statistical software to produce that. All right, so in SPSS, the way you do it is you go descriptive statistics and explore, and this explore procedure is going to give us our box plots. It's going to give us our test for normality as well. So not too many options there, pretty easy to find. You have to click over your BMI, you click over your diabetes as a factor list, so what you split your cases by, you select your plots option, and you ask for, your normality plots with tests. It will by default give you a stem and leaf as well without even asking it. You can ask it not to give you that, but you can select a histogram as well, and it will by default give you a box plot unless you specify otherwise. So again, a lot by default, it's giving you a lot of things without particularly asking for it. It'll also give you a summary of all these statistics, mean, median, skewness, you name it, it will be in that descriptives table. So we get out our normality tests. It gave us both a Kolmogorov-Smirnov and a Shapiro-Wilk, and it gives us our box plot as well. To run the t-test, we do analyze, compare means, select independent samples t-test, and what you then have to tell it what variable you want to perform the t-test on and define the two groups that you'll be selecting. Again, a lot of clicking buttons in order to get to where you need to get to, but it's not too bad. It's pretty user-friendly. Out pops your output. It will give you your equal variances assumed, or your pooled t-test and your unpooled t-test in the same table. And it also gives you your Levene's test of equality for variances in that same table, so that you can choose between them which ones you want to give. Which test is the more appropriate to be using here. And it'll also give you your effect sizes. It'll give you some group statistics. Like I said, it gives you a lot of output without necessarily asking for it. If you want to use syntax, this is what the syntax looks like. So again, it's kind of procedural based. You have to specify all your arguments, but at least you can, copy and paste this, make your analysis reproducible. In Stata, you have to well, to get a box plot first, you select under graphics, you select box plot. You have to select what variable you're after. Now, you can see that the language here isn't the most user-friendly. Um, there's a lot of options here that might not be particularly clear to everyone. Um, grouping variable, you select what the grouping variable is. You click OK, and you can get your base graph. If we have a look at how to get your Shapiro-Wilk test, you go to this summaries, tables, and tests, but you can see there's lots and lots of options here. Then you go to this sub-menu under distributional plots and tests, and that's where you will find the Shapiro-Wilk test. Now, of course, if you're a statistician, you're going to know that the Shapiro-Wilk test is a distributional test, but I'm not sure many non-statisticians or many people not too familiar with statistics is going to be familiar with that kind of language. It will generate code for you, and the code is quite simple, and it will give you your output. Under statistics, summaries, tables, and tests, to get your t-test, you do classic tests, or actually this is to do the Levine's test. You go to summaries, tables, and tests. You go to classical tests of hypotheses, and that's where you can select the robust equal variance test. Again, that language is just not entirely that accessible for new users. You specify your arguments, and it gives you some pretty good output as well. And then to actually run the t-test, summaries, tables, and tests, classical tests of hypotheses, and then you will select t-test mean comparison test. And that's when you have to select exactly what t-test you want to do, whether you want to assume equal variances by default or unequal variances, and then you can run the test. And again, the output looks quite nice, and the command is actually quite simple too, which is great. So if we look at the syntax involved for Stata, it's actually really straightforward syntax, right? It's a command and then the dependent variable and the variable you want to split it out by. But, you have to kind of learn this. So if you're someone who knows the commands, it's going to be really useful. If you're someone who's new to this using the menus, it might be a little bit difficult to access. All right, SAS Studio. For SAS Studio, you can click on tasks to obtain the statistics menu. You have to kind of find it under this tab called tasks and utilities, which could be a bit tricky to find if you don't know what you're looking for. Also, getting your data in is a bit tricky as well, but I haven't shown how to do that here just because I'm worried about time. You then select the data you want to be using, and from that, you can select your continuous variable and your classification variable. That will give you your box plot. Looks good, looks like a box plot. Move to our next step. Now, in order to perform the Levine's test, you actually have to run a one-way ANOVA in SAS Studio because that's the option where you can find it. And so again, if you don't know that, that can be quite tricky to think, oh, I want to run a t-test, but I have to run an ANOVA to check my equal variances assumption. And that allows us to get the output though. These options here aren't too bad. Although again, some of this language might be a little bit difficult for a new user. To perform a normality test, it's done automatically as part of the t-tests. So that's okay. You just click the t-test option and it will do a normality test by default and eventually give us output that looks quite nice, gives us our summary statistics of the tests, as well as our final outputs here as well. But as you can see, there's no Levine's test to help us decide whether or not it's right to compare to use the equal unequal t-tests. And then this is what the syntax looks like. So the syntax, very specific to SAS, very procedural based. might be quite tricky for someone to learn off the bat. All right. Sorry, I'm plowing through this because I'm wary of time. But and I just wanted to really kind of give you a taster of what each of these things, what each of these softwares look like. So for Python, our question is that this is done in Jupyter Notebook, so you can see we've paired text with the code as well, which is quite nice. We can actually embed our code with our text. You import your data set uh, using uh, the pandas package, which I haven't shown you loaded in. And then also we can produce our box plot. We specify what the column is. We specify, what the different categories are. And then with arguments, you can specify other parameters as you go. To get some descriptives, you have to say, well, what variables you want to do descriptives on. So you extract out these two columns. You then group by the diabetes variable and then select describe, and it comes up with a nice descriptives table for you. Um, in order to do a normality test, you have to import another package. And also you have to specify exactly, which case of diabetes you want to look at each time, which means you have to subset the variables. So again, might be a little bit tricky for those who aren't used to um, coding. And it gives you your output by default in this very kind of long decimal place um, way, which means that in order to get this to format a bit nicely, you'll probably want to, print out a formatted version of your tests as well. Um, you got your homogeneity of variances tests. Again, you have to specify exactly which subgroups you're dealing with. But the beauty of this is it's only going to give you exactly what you asked for. I asked for a Levine's test. It gives us a test statistic and the p-value. We asked for a Shapiro-Wilk test before. It just gives you the Shapiro-Wilk test and the p-value. We asked for descriptive statistics. It only gives us descriptive statistics. It's very much, if you want something, you got to ask for it, which means you're not going to be overwhelmed with output. And to perform the t-test, we can then do it using this t-test underscore end command. We specify the data sets. Again, we have to subset them by the different cases of diabetes. And we can then print out our t-test statistic, a p-value, as well as our difference in means as well. Right. And if you want confidence intervals, you have to kind of you'll either have to call a different package or you'll have to kind of compute them by hand, which can be quite confusing if you don't know the calculation. All right, in RStudio, in RStudio, we'll need to install packages if you're a first-time user. So I'm going to install the tidyverse and car packages. The car package will actually be needed for the Levine's test, but everything else you can do just with base R. So the standard package is already in R. You load the data in, you can get quite a nice output of it. It's quite simple. You can factor the diabetes, so we can treat it as a categorical variable, make sure R knows that. And then to get a box plot, we tend to use this symbol here, which I always think of by, BMI by diabetes, specify the data set, and then you can also, change parameters for the actual graphics as well, change the colors, change the labels, or by just changing the arguments here. I think what's great about this is you don't need to do, data $ BMI, data $ diabetes every single time. You can use that kind of abbreviated syntax, which just makes it a little bit more user-friendly for this kind of analysis. You can also do it with ggplot and the grammar of graphics, and I could give a whole talk about why the grammar of graphics is amazing, which I'm not going to do. But you can also do this pretty easily with the grammar of graphics and in ggplot. To obtain your descriptive statistics, you can either go line by line. So ask for the mean, ask for the standard deviation, ask for the summary, ask for again, these base R packages, very simple. The commands are really simple, kind of easy to remember. particularly when we're talking about statistical analysis. And that's because R is built for statistical analysis. But there's always, multiple ways to do it. If you want to use the tidyverse in order to do that same kind of thing, you can use this. If you want to use the pipe, you could use this kind of code. So you might actually see it be done three different ways depending on who's programming it. For the Shapiro-Wilk test, very simply, we just specify the data set and the column. And we can also do that there and this is for the group 0 and group 1. And of course, we can always do it in tidyverse as well. So in order to do the homogeneity variances check, we'll need to load a separate package. All we have to do is load car, and then the Levene's test will be available to us. And we can specify a BMI given by diabetes, and it will spit out some nicely formatted output for us to interpret. And to perform the final t-test, we use that same syntax, BMI given diabetes, specify the data set, and all we have to do is make sure we specify that the variance that we're using equal variance t-test here. And it gives us, again, nicely formatted output, including confidence intervals or by default. And you can always also get access to the help documentation just using the help command. Alrighty. Now I'm just going to switch quickly to Jamovi just because I wanted to show you what that looks like. If you go t-test independent samples, this is what Jamovi looks like. And you can see very similar to SPSS. If you go to your data tab, you can set it up and you can switch between, a continuous variable or a categorical variable with different levels. Of course, that's probably supposed to be a continuous variable there. And you can attribute, nice labeled levels to numerically coded data, which is great. To perform your box plot, to get your box plot and your basic descriptives, there aren't too many options, right? There's 3 options here. So I go to descriptives and it opens up a little analysis window and you can see it's already starting to populate your output. So as you arrow things across, it's going to start to populate those statistics, which makes it really easy when you're trying to explain things because you can take it one step at a time. So I'm going to look at, well, this is giving me my mean for BMI, my median, my standard deviation. I click on my statistics tab and I can, there's no missing, so I can get rid of that from the output. I want to get rid of minimum and maximum, but add in IQR. You can just select those options and it automatically updates it over here. So again, you don't have to select all the options you want, hope and pray you did it right, and then click OK. And then if you didn't, you have to go back and do it again. It's very dynamic. It does it as you go. You arrow across diabetes, and it splits it up into the different cases. And you can also present it so that the statistics are going along the columns instead of the variables, which I think is a nicer way to look at these kinds of things. And it builds a nice kind of table. And from here, I can then go and edit the text straight away. To perform the t-test, I go to my independent samples t-test. I arrow across my BMI, I arrow across my diabetes, but you can see all the assumption checks that I will need to do are given in this window. So I can just click homogeneity test and it'll spit out the Levene's test for you. I can click normality test and it will spit out the Shapiro-Wilk test. And it also gives you a little hint about how to interpret the p-values as well. So very user-friendly for someone who's not necessarily familiar with all the terminology involved in statistical analysis. You can also get out your QQ plot as well. If you need to switch between different tests, so right now we've got the student's t-test. If you need the unpooled or the Welch's t-test, you just select that option. If you want your non-parametric alternative, you can just get that option as well. And that can be really useful when you might have some variables that you need to use a non-parametric test for, or some variables you might need to use a Welch's or unpooled t-test for. You can put them all in, select all the options, so you don't have to run the procedure 100 different times for every single variable. And you can also get some nice plots out. Like I said, the plots, the only issue here is that I can't do anything with these plots. That's it. So only the labels you can touch here and edit the variable labels. That's the only way you can really change these plots. And the last thing that you can do, which is quite cool, is if you click this syntax mode option, it actually shows you the R code that generated this output. And if you were to copy and paste that into RStudio, as long as you've got the JMV package installed, you can actually do all of this and get all this output in R. So it might make it a little bit easier for someone who's started in Jamovi to start to transition into R. You can get your data set up in Jamovi and save it out as an RDS file and load it in R and go straight from there. There's even a package called JMV Read and Write, which allows you to communicate with an active Jamovi session from RStudio, which is really great as well. Okay, I know I'm short for time, so I just got one more slide. So the key takeaways, Jamovi, it's good for teaching infrequent use of statistics because it's easy to pick it up again after a break. It's got some basic analysis methods. It's easy to learn and it's got good default options. Python's great for machine learning, AI. It's regular users. If you're wanting to integrate it with web platforms or collaborate with other people, particularly computer scientists, Python is a really great software to use. RStudio, if you're really focused on statistical analysis and you're a coder, data manipulation, visualization, advanced analysis, all of these things are really, really good in R. SAS is a good overall package for big data and for administrative data with confidential information. Really good, useful, like so, particularly for government and pharma. SPSS, good overall package for your standard analysis, and STATA, again, good overall package, but particularly good when you're dealing with survey analysis and meta-analysis in SEM. Alrighty. I'm gonna wrap it up there, but I'm gonna leave this take-home message up on screen so you can have a read and we can have time for questions. Is that right? Yep. Cool.
Yeah, hi. Hang on a second.
I've got a question in the chat. It says, "Hi Bradley, I was wondering what is your opinion on usage of Graph Prism in science research environment?" Great question. I've had a few people who've used Prism, um, who I've interacted with, and I actually think the way it labels the statistical analysis, I was kind of ripping on Stata for how it was labeling the methods in the windows. I think Prism is really good at making that very accessible, particularly for scientific researchers. Um, and so I have no real problem with people using it. I'm all for people using whichever they feel comfortable for. But of course, it's going to have that limited capability as well. I think there weren't all the analysis methods that you can use. But again, I'm not a big Prism user. I have had people who've used it and GraphPad. But yeah, I think what I do think the way it labels their commands is really useful. Yeah. Um, Sorry, I use Power BI for visualizations of the data and dashboard reports. How useful is it for data analysis? Look, Power BI, I've used it a bit. It's really meant for your building those dashboards and reporting more than statistical analysis, in my feeling. If we're talking about actual running statistical inference and statistical tests, that's when you would probably want to be moving to a statistical software. In saying that, you can integrate R and Python, I think, into Power BI. So you can actually run those analysis commands within R and using R and Power BI commands, and then integrate that into your Power BI reports. There any other questions that I've missed?
There's a question about whether you can do latent change score models in the Jamovi interface.
I don't think so, but I'm not sure. Because there are a whole range of modules, so I'll put them up so you can kind of have a look at what's available. Sorry, I've got too many windows open, so there we go. If if you go to the modules option here, you can see there's, a whole heap of different um, methods that you can integrate in. I'm looking for,
Oh, yeah, there are quite a lot, aren't there?
yeah, like there are lots of things in here. We got latent class analysis. Yeah, anyway, sorry, getting distracted. But yeah, so there are additional analyses within there. There are all varying qualities because it is, of course, an open source thing. So this is based on the the developers, how user friendly those analysis methods are.
I had a question, Brad. I was
Yeah.
wondering what your take was on how the different statistical softwares might guide people to like more correct methods. So sometimes I feel like what
Mm.
people end what people end up doing with their data and their research question depends on what software they're using. And yeah, do you see that as well?
Yes, yes, absolutely. Because people will just kind of click whatever options sounds the most familiar or the most kind of useful to them. I kind of I think that's why with these types of commands, usually keeping it as simple as possible is the best. Um, just because, and that's also why I like Jamovi because it doesn't say compare means and it doesn't try to explain it. It just says t-test, which means that you're going to have to know what test to use in order to select the right option. And that's also the case with, say, your coding-based languages. Um, and so using something that where it gives you these long explanations can be quite confusing. I I would like to think, though, people are asking if they're unsure about the analyses, and that's why, if you are unsure, it's always good to ask a professional or ask someone who might know. That's the best point of call, I think, from my perspective. I usually just encourage people to come and see me and email me with their questions.
And I have another question. Oh, there's one in the chat first. We'll go to that one. Is there a current alternative to nQuery for sample power calculations that require flexible options?
Um, there are so within there are power calculation packages within R, which I'm kind of used to and familiar to, but they're not the most user-friendly to implement. So you can do it in, say, something like R and Python. Um, I've seen G-Power used quite a lot for those kinds of things, sample size calculations. There's also a lot of online tools which can be quite useful. Although I always I always uh, hesitate to recommending people just go Google because they always end up using the wrong calculator for their projects. So, um, yeah, outside of that, I think SPSS does have power calculation tools within it. Again, it's not the most user friendly, and it's fairly limited in the options available. And I think Jamovi too does have some sample size calculation options. Again, very limited options though. So, yeah.
We like PASS, PASS,
Oh,
or
yeah.
yeah, that's a good one, but it's quite expensive. So
Okay. Yep. Yep.
yeah, so
Yeah.
it's not necessarily friendly for anyone to get involved in.
Yeah. Okay. Yep. Yeah. No, I haven't used that one. So we don't tend to have a lot of statistical softwares available
Yeah.
that that are paid for at UoW.
Yeah. Um, there's a great question in the chat. Can two software produce different results for the same problem? If yes, then which one should be accepted?
So in practice, yes, but in principle, no. So, and it really depends on very specific analyses. For all your standard tests, they're all going to give you kind of the same thing. You might get different levels of decimal places, but they're going to give you the same thing. There are some calculations though where different methods might be applied. And one that springs to mind is when you're computing quantiles. So if you want to compute, your median, um, there can be a bit of difference that happens between the different statistical packages. Uh, and it's not because some statistical packages do it wrong and there's only one right way. It's because there's multiple ways to compute quantiles. And so as long as you're kind of being upfront with which method you're using or which software you're using, you should be okay. You should be fine. But yeah, in general, not really an issue. And as long as you say, I'm using this software to perform this. But yeah, like I said, it's only for very specific types of analyses where you might see variation occur between the different softwares.
I think that might be it for questions in the chat. I had just one more, just to keep you on your toes. So Copilot in R, I've seen a couple of people using it. I haven't used it myself, but
Yeah.
it seems like it's like a new software in that it's this is a large language model that's predicting your code for you. So it's like greatly reducing the
gap, the learning curve.
entry.
Yes,
Yeah.
absolutely. No, that's a great point to bring up, particularly with Gen AI now, that being able to learn coding or getting the right syntax is kind of getting easier and easier. And I hope we'll eventually develop to the point where we just ask the computer to what we want and it will be able to do it. It can do that a little bit with ChatGPT at the moment, but it makes a lot of mistakes and you don't really want to be trusting it too much. But yes, Copilot is a very useful tool. I don't use it. I think it's because I'm probably too arrogant to think that my code's going to be better than what's suggested. But I know like Marika uses it a lot for her coding. So very, very useful tool. It basically start typing your code and it suggests what you want it to happen next. And you can even comment up the top what you want it to do and it'll suggest commands as well. So really helping to bridge that learning gap. And very useful when you forget commands because it's very easy, very, very easy to forget specific syntax. And so it can propose it. Oh, that's right. That's what it wasn't a capital there. It was a lowercase or something. RStudio has a little bit of that as well, but you have to get the first 3 characters right of the command before it starts to pop up and suggest what the thing was.
And Natalia's asking, is there a best tool if funds are limited to none?
Yeah. So that's why open source. So it was a big thing. So the Jamovi, the one I was showing you just then, completely free. You can have it on your computer, in 5 seconds. You just got to Google Jamovi. Luckily, it's a distinct enough name to not get multiple hits. You'll probably just get the right software. So but it does depend. R and Python are also open source and free, but of course they're more difficult because they are coding languages and they've got a steep thing. But yeah, Jamovi definitely. JASP is also another good option. I know a lot of people are using JASP. It has better data visualization than Jamovi. Although I think JASP and Jamovi had a shared developer in Jonathan Love, who's an Aussie guy too. So I should say that Jamovi was developed. 2 out of 3 researchers, I think, were Aussies. So that's also a big plus if you like that as well.
And I'm not sure, but if you are UNSW, Natalia, it's worth checking what's on My Access. So because SPSS and SAS are available on My Access. Cool. Well, thank you so much for coming to this talk.
No worries.
Really appreciate it.